Hey guys, welcome back to my channel, and today we're going to be looking at Geology Part 3. Today we're going to be looking at tectonic plates, fold mountains, and the earth inside. So this is the earth when it's cut in half. We've got the core, we've got the mantle, we've got the crust. So today we're going to be looking at the crust and the area around it, so like this bit. If I zoom in on this bit, it will look like this. You've got three different layers. This main layer here is the mantle, and this layer here is the crust. We're going to be looking especially at the crust today, so let's move on. The Earth's surface is made up of many different, let's say, sections. It will probably look something like that. That's just a guess. And these sections are all different. And the real ones would be called tectonic plates. Now, tectonic plates are what make the crust, and there's suspected to be quite a few of them. So we're going to go straight on and look at fold mountains. Fold mountains are all about tectonic plates. So if you've got a tectonic plate here and a tectonic plate here, what's going to happen is this plate is going to start moving that way, and this plate is going to start moving that way. Eventually they're going to meet down there. When this happens, there will still be pressure on either side. They'll be still pushing from here. So the pressure on here will cause this to rise up by pushing against each other like this. So now they're pushing against each other, and eventually they'll come up like this. And that is what forms a mountain. There are other different ways of making a mountain, but this is called fold mountains. And you could demonstrate this by using a rug. And on this rug, if you push on either side, you'll notice that by pushing on either side, it will start to begin to look a bit like that, where it was before straight. And that's how these work. Another kind of mountain is called a fault mountain. So this is one where you have two tectonic plates next to each other, and they're acting in different directions. We don't know much about these, so eventually what we do know is this one of them, because the pressure is coming from this way, this one will gradually move up. Mountains that are fault mountains are often have a very steep side. So they're very pushing up, and they have a very steep side to them. So you could identify them by that. Now we're going to move on to volcanoes and things like volcanoes. So volcanoes are different to mountains. So what happens is it can happen at the ocean. So you've got an ocean plate here, and you've got a land plate here, and this land plate, draw that on, that's for land. And what happens is this plate is a lot heavier because it has the mass of the water on top of it. So this plate pushing against this plate, and they're pushing against each other down this middle line, will make this plate drop, and this plate will stay there. And you'll continue to have that, but this time, now this is getting pushed downwards, and this is still moving forwards. This can cause a lot of pressure to be underneath it. So this pressure pushing up here can force magma to rise, and eventually burst through the surface into either volcanoes, forming mountains first, then through to volcanoes, or fire spurts straight out the ground. Now we're going to look at what I probably should have looked at the first part, was the Earth and how it's moved. So it's thought that the world used to look a bit like this, and scientists call this Pangea. So what's happened over time is the plates have moved, and it's thought that the tectonic plates, move about 1 inch to 2 inches every year. So over about 400 million years, if not more, the plates have moved around, and they have formed Earth as we know it today, which I'm not going to try drawing. The interesting thing is, tectonic plates can have an ocean or land on them. So if you were to get all the vegetation off of Earth and all seawater off of Earth, you would be left with raised parts, which would be the land, and lower parts, which would have been where the water was. And tectonic plates flow through all of these, and I'm going to use this red pen to show where tectonic plates might have been. They can be all shapes and sizes, coming straight through. They can either have just land, just water, or both. It doesn't matter, but this is something what it would look like without water or vegetation. If we zoom in on this crack here, there will be 2 plates with a gap in the middle, and it's when these 2 kind of plates push together that you get fold mountains and things like that. So the final thing is, we're going to look at earthquakes and how earthquakes are made. So bear this in mind. And we said that 2 plates would be next to each other, and they'll be pushing opposite ways, and they might eventually touch, and when they're together, when they're pushing opposite ways, this will produce a lot of weight energy, and they'll send energy spiraling out in directions from millions of miles. It can be up to well, as big as the biggest earthquake has ever been, probably. So this is how the waves sent out in a shock energy like this, and this energy, this is underground, and sometimes the energy is sent far enough that it can reach the surface and the crust, and when it does, it causes the crust to vibrate, and that's why an earthquake will happen, because the surface is vibrated. So, thank you for watching today. It's been great fun doing geology. That'll be the last geology video on the basics. I might go into more depth in another one. So, thank you for watching. Goodbye.